Greetings, M Squared here. Today we are going to talk about solving systems of equations by graphing. So this is our first lesson on this. Your homework is going to be on Delta Math tonight, and we want to know what a system is. If we're going to be solving systems, we might want to know what it is. So a system of linear equations, that means lines, is just a collection of two or more lines, two or more linear equations with the same variables. So remember, all our lines have had x's and y's. So we're going to have two lines in our homework. Now you could have 3, 4, 5. You could have lots of different number of equations, but our system is just going to have two, and we're going to have x's and y's. Now a solution, if you're asked to solve, you might want to know what a solution is. A solution to a system are the points where they intersect. So you're going to do three things tonight on your Delta Math homework. The first thing is you're going to find solutions to systems. Now these aren't linear systems. Notice this is not a linear graph. That is called a parabola. It's a quadratic function. This is a linear function. So this is a line, this is a parabola, and we are going to solve it by looking for the solutions. And remember, the solutions are where the graphs intersect. So we're just finding the points where the line and the parabola meet. So there's one point right there and one point right there. So the solution are those points. The solution is those points, I guess. 2, 2. 2 to the right, 2 up. So one of my solutions for this system is 2, 2. The other one is right here, and that would be 4, 6 over 4 up 6. So it's that easy. A solution is just simply telling what points the graphs are intersecting on. So we'll do one more of those. So where do these two intersect? Well, right here and right here. And so if we write those 2 points down, it's -2, 3 and 0, 7. And those are our solutions. Okay, so that's one thing you'll have to do is just look at the graph and find the solutions. So then we'll move into actually having just two lines. And it's important before we get started on solving systems that you understand the three possibilities, because there are always three possibilities when you are solving a system of linear equations. When two lines get together on a graph, one of three things can happen. You can have one solution, they intersect at one point. You can have no solution because they're parallel, or you can have an infinite number of solutions because at every single point they're intersecting because they're the same exact line. So you're actually graphing a line on top of the line. And so that would be an infinite number of solutions. Now these, when you see a picture of them, it's pretty obvious. One solution, no solutions, infinite number of solutions. As long as you know there were two lines, it would be obvious. But you won't always have that. You won't always have the line. Sometimes we're going to use algebra to figure that out. So we want to know how to tell if we don't see a picture of them. And that's what this chart is about. So for one solution, when they intersect once, their slopes must be different. And it's pretty easy to tell right here. These are in slope-intercept form. The slopes are 2 and -3. Those are different. It really doesn't matter what the y-intercept is. It can be the same or different. But if the slopes are different, that's how you're going to know you have one solution. So really, it's all about finding the slope. That's the first thing you're going to do to find out how many solutions there are. We'll talk later about how we find the solutions, but part of your homework is just finding how many solutions a system has. So right here, you'll notice the slopes are the same. And for no solution, for parallel lines, you have to have the slopes the same. But the y-intercepts must be different. If they're the same, that's over here. So they'd be the exact same line. So we want to make sure we know that the slopes are the same and the y-intercepts are different. That's how you get a no solution. And then to get an infinite number of solutions, the slopes have to be the same and the y-intercepts have to be the same. And notice if it's in standard form, sometimes the same line, you see how this is this equation multiplied by 2 is what you get down here. So sometimes if you just like divide everything by 2, you'd get x minus y equals -3. Then you could see that they're exactly the same. So that's another way to tell if it's an infinite number of solutions, is by simplifying one of the equations. Okay, so we have 4 problems and we're going to find out how many solutions they have. Next we'll do what is the solution, but for this one it's just how many, which means we have to find the slope. So remember, all of these are in standard form. So the easiest way to find slope when things are in standard form is -a over b. And remember, standard form is ax plus by equals c. You should know that, but just to put it down in case you don't know. So we're going to take this, the opposite of the number, the coefficient of x, divided by the coefficient of y. So negative 1 over 3, remember, if there's no number, we can assume it's a 1 right there. So the slope of this guy is negative 1/3. The slope of this guy is negative 2/6, but that reduces to 1/3. So you have to be careful that you reduce. The slopes are the same. So now we have to figure out, well, are the y-intercepts different or the same? Because if they're different, it's no solution. If they're the same, it's an infinite number of solutions. So I like to do that just by dividing by the common denominator here and seeing what I get here. So I get x plus 3y equals negative 3. Well, my c's are different. That means they're not exactly the same. So there we go. That's a no solution. If the slopes are the same, that means they're parallel. If the y-intercepts are different, that means that's what tells you they're parallel. This could tell you either the same line or parallel. All right, let's try another one. So negative a over b is negative 5 over 1, negative 3 over 5. Okay, those are no way going to be the same. You can't reduce any of that to be the same, so we just know there's one solution. All right, over here. Okay, this is interesting. If I notice that, well, I'll find the slopes first. I notice something else too, but you might not, so I'll do that. So the opposite of 1 over 2, the opposite of 5 over negative 10. So they both reduce to 1/2. But then I notice these are all divisible by 5. What happens when I divide that whole thing? Well, I might as well divide by negative 5 because those are all positive. I get x plus 2y equals 16. That's the same exact thing. So that means there's an infinite number of solutions. All right, one more. Let's find the slope. The slope is negative 3/4. The slope here is negative 3/4. The y-intercepts are, not everything is exactly the same. So I could take, let me try a different color. So I could take and multiply both sides by -1, and then I notice that x's and the y's are the same, but these aren't. So that means they're parallel. There's no solution here. All right, so that's how you find out how many solutions. And lastly, we're actually going to solve by graphing. So we have two equations. We're going to graph both of them, and then we're going to find the point where they intersect, because that is our solution. So our first one is x plus 2. That means the y-intercept is 2. Remember, there's a 1 sitting there if you forget. And so the slope is 1. So I go up 1 over 1, and I can go back and forwards. I like to do as many points as possible when I'm graphing because it's hard. If you just do a couple and your line's off, you might not find the point where they're supposed to intersect. It can be tricky. So this one is a -4 and then a -1/2. So up and left, and I see right there that it intersects. If you don't see exactly where it intersects, you might be a little off. You want to check your slope. Did you forget that it's negative? Because there's lots of little things that can go on. And I'm going to show you a trick here. So -4, -2 is my solution, but I can always check to make sure before I click submit on Delta Math by plugging the x and y in here. You don't have to do this if you don't want to, but if I say, oh, well, y equals -4 plus 2, is that true? Yeah, that's true, right? -2 equals -2. And if I do the same thing for that second one, I get -2 equals -1/2 times -4 minus 4. Well, this gets me a positive 2, and 2 minus 4 is -2. So I can see that that point actually does work in both of those equations. That's how I can tell that I'm right for sure. Okay, just a couple more. So our y-intercept is 6, our slope is 1. So we're going to graph that line. And then our slope is -3 and our y-intercept is -6. So up 3, left 1, up 3, left 1, up 3, left 1. And I see a nice little spot where they're intersecting, so I'm pretty sure I'm right. Of course, you can always check it like I showed you. So that's -3, 3. That is my solution. Okay, one more. Now you can always, when I look at this one, I'm like, oh, what do you notice? Slopes are the same, y-intercepts are different. I expect these lines to be parallel. If you don't notice that, you hopefully will notice it after you graph it. So if we graph this top one, we have a y-intercept of 4 and then a slope of -2. So I'm going to graph that one. And then a y-intercept of -1 and a slope of -2. And we'll see that they are indeed parallel, although mine are a little messy. So it looks like they might intersect eventually, but that's just my problem. All right, so those are the 3 things you have to do. You have to solve by graphing. So you're going to graph 2 lines, find the point where they intersect. For example, this, I forgot to write it down. This would be no solution. You're also going to have to find out how many solutions without graphing, and then you'll have to find the solutions of the graph. That's what you're doing tonight. Good luck. M Squared signing out.